Okay, so for alkene stability, you need to look at two things. The first is number of substituents, and the second is if they're the same number of substituents, then you rank it by trans, geminal, then cis. So what that means is the greater number of substituents, the greater the stability of the alkene, and if they have the same number of substituents, then trans will be more stable than geminal, and geminal will be more stable than cis. So let's do a practice problem. So just rank the stability of the alkenes from 1 to 5, 1 being the most stable alkene. So try this out first, and then I'll explain it. Okay, so let's just follow the rules, right? So number of substituents. So over here, this alkene has 3 substituents. This alkene has 4, right? 1, 2, 3, 4. Over here, this one has 1 substituent. Over here, 1, 2, 3 substituents. And finally over here, 2 substituents, right? So now what we do is we just look at everything we know right now. So we have 4 substituents, 3, 1, 3, and 2, right? So we know that this will be our most stable, and this will be our least stable, right? And then this will be in the middle. The only thing we have left is these 2 molecules, right? So we have same number of substituents for both of them. Now we have to look to our second rule. If we have the same number of substituents, then we have to look at trans, geminal, and cis. So trans, right? Trans, how do you determine if this is trans or cis? So in this case, for over here, you look at priorities. So technically, it wouldn't be called trans, it'd be Z, you'd be using the E and Z notation, but you can just remember the acronym TGC to help you remember it, but just remember that you're using the E and Z priority system. So the priority system is, over here, the carbon would get the priority 1, right? And since this has less carbons, it'd be 2. Over here, it'd be priority 1 for this carbon, and the hydrogen would get 2. So the 1s are on the same side. So it would be Z, right? It would be on the same side. For technically that would be cis, right? Because cis is on the same side. Over here, the priorities are on the opposite side, right? So 1 and 1, opposite side. So it would be E. And so since they're on the opposite side, it would actually be trans, or E. So since this is trans, right, this would actually be higher than the cis, right? This is on the same side, this is on the opposite side. This would be trans is higher, so therefore this will be higher than this one. So if we look at our answer, we have 4 substituents, that'll be 1, and since we just determined that this is trans, this will be 2, 3, and then this one has 2 substituents, 4, and then since this has the least amount of substituents, we have 5. So I hope that helped, and thanks for watching.